Alrighty, here we go. Day 23. Fingers crossed this doesn't just go from 0 to 100 really quickly here, but you enter a large crater of gray dirt where the grove is supposed to be, and all around you plants you imagine were expected to be full of fruits are instead of withered or broken. A large group of elves is formed in the middle of the grove. But this volcano has been dormant for months. Without ash, the fruit can't grow. You look up to see a massive snow-capped mountain towering above you. It's not like there were other active volcanoes here. We've looked elsewhere, or looked everywhere. But our scanners show active magma flows. Clearly, it's going somewhere. They finally notice you at the edge of the grove. Your pack almost overflowing with the random starfruit you've been collecting behind you. Elephants and monkeys explore the grove, looking concerned. Then the elves recognize the ash clouds slowly spreading above your recent detour. Why did you? How is? Before that, anything can form a complete question. Another elf speaks up. Okay, new plan. We have almost enough fruit already, and ashes for the plum should be spreading here eventually. If we quickly plant our new seedlings now, we can still make it. The extraction points spread out. Elves reach. Okay. There's enough time to let the elves figure out where to plant the seed themselves, and you quickly scan the grove, puzzle inputs, and note their positions. For example, the scan above shows elves and empty ground. Outside your scan, more empty ground extends along the other direction. Scans are oriented to the north is up. Okay. The elves follow a time-consuming process to figure out where they should each go. You can speed up this process considerably. The process consists of some number of rounds during which elves alternate between considering where they move and actually moving. To the first half of each round, each elf considers the 8 positions adjacent to themselves. No other elves are in those adjacent. Or well, it sounds like a game of life here. Oh, this is game of life. Okay. After each elf has a chance to process a move, the second half of each round begins instantaneously. Each elf moves every square. Okay. None of those elves move. Finally, at the end of the round, the first direction. After each elf has a chance to propose a move, the second half of the round can begin. Simultaneously, each elf moves to proposed destination tile. If they were the only elf to propose moving to that position, none of the elves moves. Finally, at the end of the round, the first direction the elves considered is moved to the end of those directions. For example, during the second round, the elves would try proposing to move to the south first, then west, then east, then north. On the third round, each elf would first consider west, then east, then north, then south. To make sure they're on the right track, each elf likes to check after round 10 that they are making good progress toward covering enough ground. To do this, count the number of empty grid. Okay, dude. Why is this so? This is just the reading on this is a bit just cumbersome, I guess. So we have to load each elf in, and so what the elves are doing is, so it's game of life, but there's no elf. The north, northeast, northwest, using the elf preservers mid north one step. Finally, end of the round, the first direction the elves considered is moved to the end of the list of directions. For example, during the second round, to the south first, so it's north, south, west, east, but then it goes, okay. So we need a list. So I guess what we're going to be doing is just going to be a list of points. And this is going to be elf positions is going to be equal to new array list. I equals 0 while I is less than input dot size. It's technically a row. I should probably mark this as row instead of I. Row. And then column. String s equals input get row. S dot length. Column plus. So point p equals new point row column And go ahead and add our elf positions here. So we have our elf positions. That was easy. So now we begin the game of life. So 10 rounds. So for int I equals 0, while I is less than 10, I plus plus. So we have to go through and figure out which elf, what they're all proposing. So we actually are going to need, instead of a point, we're going to need a class elf. Whoops, ooh, public point elf. So that's gonna be a list of elves. This is gonna be public elf. It's gonna take in a point, what? Nope. A point position. This dot pause equals pause. Okay. So we have our elves. So, each elf, can I just go back to day 22 and copy this direction class? Just give me this enum here. Just give me this enum. So what's going to be happening here is each one is going to be a list of direction equals arrays. Choices, I guess. So it's actually north, south, east, and west. Ooh. South and west, right? West, east. West and east. Okay. So we have the choices. So what we need is we need a public point get choice position. So it's gonna go for direction D and choices. Actually we should go this int I equals 0, while I is less than choices size I plus plus. We're gonna need to do this because we're gonna need to remove it when the time comes. So there is our direction. So north, northeast, or northwest. So let's do a switch on D. Case north. We're gonna need a list of elves, but this isn't going to be a good idea because we're going to need to make this a map because this needs to be a position or a point. Sorry, this would be a hash map. So I guess this needs to be changed. Point P. Oops. Put P and elf P. So this also needs a map of point and elf. So, point northeast is going to be new point. row, column. So it's gonna be row +1, row -1, right? And then east is column +1. And so we just do if else contains key break. Because if it contains, we don't want to move here. If it contains north and northwest. So I guess if it does not contain that, then we're free to move there. So that's what we return. D, I guess. Oh, not to return D. Return this. Point north equals this. So that's going north. Check that. Return north. Okay. Case south. +1. This becomes south. South, south. These all become a plus. Okay. South. West. So west is -1 on the column. -1, -1. And then we're checking northwest and southwest. This is west. And then last but not least is east. And just flip all these to a plus. And we're good. All right. Get rid of these. I don't know if we're gonna need change. Let's just drop this. I don't know if change is actually gonna be needed, but we'll find out. I guess what I could have done is I could do d dot change, and then I could do north row. That way I don't have to do this every time. Not change. Did I delete the move? Oh. Really? I deleted the move? I don't know why I'm doing this. It's just wasting time, but you know. I've committed. I've committed now. Oops. Unless I do that. Okay, and then last but not least, west. Oh, this needs to be east, by the way. East, 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 east. Move this. Okay. Now that I've wasted time doing that, and I guess this can return position. Sure. So here's our choice positions. I guess I can enhanced. Oh no, we gotta do this, and then what we need to do is, I guess this should be left as break, because if we do choose this, Now we do choices, remove I, and then choices, add D. So removes it and then adds it to the end. Whoops, I forgot the break. Okay, so now we can go through is we now need to build up this list. So they all choose their position. So we do mount, this is to move. What happens? Can an elf? No, elf can't move to where they just went. Right. So luckily, because we're using a map here, what we can do is we can do we're also going to need a list of points, and this is bad luck. And so now we're going to go for elf E in elves. Values. We're going to go E dot get choice and give it elves. Point P. And what we're going to do here is if bad luck contains P, or if it does not contain it, we are good. If it does contain it, well, it can't move anywhere. If it does contain, we need to do to move put E dot position E. The bad locations, if it does contain it, we need to do a check here. Does to move contain P. If it does, this is a bad location, so we do to move remove P and bad lock add P. But we also need to, this is the elf that's being removed. So this one is being removed, so we need to then re-add it to move put removed. Take its original position, add it back to move, and then also add this elf back to move. Otherwise, we are good. So go ahead, add this P, and we're good. So now, after this, what should be able to happen, we should be able to do is at the very end, elves equals to move. And that we should be good, right? Done. So now what's it asking? How many empty grid tiles does that rectangle get? So simply the elves find the smallest rectangle that contains the elves after 10 rounds. So this is easy. We need to find the minimum and maximum of each. So no max value. We need to find our 4 values. Min Y, max Y, and this is min value and min value. So now for point P, ooh, this is gonna get dicey. This might become way too inefficient, but we'll see. I think this might be too inefficient, but we'll see. Okay, and next, so if p dot row is greater than max y equals p dot row is less than min y, and then flip these around for the columns. And now we have our box, so now for int I equals, or for int row equals min y, while row is less than or equal to max y, row plus plus. This is where it's going to become very inefficient if it does. Point p equals new point. It's probably me just allocating all these points because these weren't meant to be done like this. If elves contains key p, if it does not contain key p, empty plus plus, lap empty. How inefficient is this? It's so inefficient, it doesn't even run. Okay. What went wrong? Okay. Okay, so this worked. Wait, that worked. So the elves is, okay, that worked. What? 070. Oh. The heck? I'm dumb. I forgot to parse the line. If s dot char at column equals what? I'm guessing the elves are the this. Wow, that was not smart. Hey, look at that. Unsupported what the heck? I've never seen an unsupported operation. Oh. You can't remove from this. Can you remove that? No. Okay, fine. New array list. You know what? I don't want to fight this right now. I really just do not feel like fighting this. okay, that's fine. Give me an answer. Dang. Okay, example inputs. What do you get? 28. 110. Oh. Oh, okay, wait, it's fine. So end of round 10. So what we can actually do is I can just do a system out print line. This is a print, and this is going to be contains. If it else does contain, we have that. Otherwise, we put that and print line. That doesn't look right. That looks like it does after one movement. Hey, that looks like the initial state. It looks like almost identical, like the initial state. Huh? So that's the initial state. So they honestly did not do anything. So something's messed up. What did I mess up? So this is elf. So this elf is at row 4, column 3. Zero, 1, 2, 3, 4. 0, 1, 2, 3. So that one. And his choice was 4, 3. Well, I can tell you right now, he could have moved to the north. I forgot to flip these all to be that. My B. That still does not look like it should. North, south. Those being backwards doesn't help either. Okay. Still not ideal. What's going on? So what's choices? Southwest, east, north. Yeah, that's right. Turn north. Good. So this one is 4, 4. 0, 1, 2, 3, 4. So it's this one. This one can't move anywhere. So that's right. 5, 5. It can't move anywhere. 1, 2. It can't move north. Okay. Let's instead take this and let's do private int with map point elves include boolean so now we can do lap get empty elves fall let's do true for now. What we can also then do is what did I miss? Return empty. Okay. So wait, the first move actually worked just fine. Wait, did the first one worked perfectly? Why does the second one break down? Huh? Give me the even smaller one. Yeah. What the heck? Why does this just break down after 1? We set elves equals 2 moves. We reset 2 move, reset bad. Two move has all the elves. What am I missing? 1, 2, 3, 4, 5. Yeah, so we don't lose any elves. They just don't move correctly. So these move south. I don't understand. What is happening? Oh, we do lose an elf. Something is going wrong on the second iteration. Okay. This is our first elf. Our first elf is 4, 3. 0. 0, 1, 2. Wait. Dude, the fact that these are done like this. Oh, wait. Okay, no, they don't move. So 0, 1, 2, 3, 4, 1, 2, 3. Okay. 0, 1, 2, 3, 4, 1, 2. I don't change the elf's position. I see, I see, I see. I see. Elves, key sets. Elves get P position equals P. That's what's happening. I forget to update the elf's position. Okay. Let's try that again. So it goes to that, and we still break down. But not as badly. Only one elf failed to move correctly. So this is right. This one drops down. Man. Okay. I can at least run in this mode though. Okay. Which elf is it? It's 3/3. There, okay. So we got this right. We're onto this. So 0, 1, 2, 3, 1, 2. There is no elf at 3/3. Oh, there it's right there. Sorry, that one. You choose to go to 3/4, which is right. Okay. Oh, I went too far. Yes, yeah. 3/3 went to 3/4. 2/2 0 1 2 0. Okay. 2/2 goes to 2/2 wants to go to 1/2. Correct. Let's go south. The remaining middle two elves, the west one cannot move south. Wait. Of the remaining middle elves, the west one cannot move south and propose to move west, while the east one cannot move south or west. Oh. I did this wrong. So no matter what, we still do that. Oh. We always grab 0 then. We don't care about I. So we always remove it. And then we always add it to the end. So we always remove it. And then add it. That then simplifies all of this. What do I get now? We got it. I think I got it. There to there. No, really. Really? Really? So we got the first 2 then. Oh. Oh. I totally forgot about doing nothing. Row equals 0. Gotcha. Row is less than, let's do -1, less than 2, row plus plus. Gotcha, column. Boolean skip if point P equals position row position column row plus row column plus column. If else contains this key, then skip equals false and break. Otherwise, if skip return position. Let's try that again. That looks right to me. That's that one. What? The first direction else considered. It's only the first. So this is still wrong. It's not this. So this is I. Okay, so whenever we return, we're gonna do choices, add choices, remove I. Before we return, we always do this. We always remove the very first one. Not I, 0. The first one considered is always moved. Please tell me this works. Holy, finally. Dude. I lost an elf. Huh? No, he just chose to go a different direction. Okay, how about this then? Run. I hate this. No, it's because I mess this up. I equals 1, or I equals 2. Because it's not the number, it goes down 1. End of round 2, round 3 is 2. Hit this breakpoint now, please. Thank you. Okay. So it skips over because it's found 1 and 1 up. Good, so it found it. Okay, so now it's south first. South, west, east, north. Why is south up first? Because where's this one? Here. You are here. You start here. You look north. And congrats, you can go north. So north is the end, so this should be a south check first. Which you can do, but there's nothing around you, so you don't do it. So now you're here. So regardless... So I guess it's regardless of... this then. Huh. Okay, so even if it does skip it, that's where it's messing up then. Just out of curiosity, round 10. That, I'm correct. Alright, YOLO. Let's put my giant one in here. What do I get? Please be right. Holy, I got it right. Alright, now how bad is it going to break? It seems you're on the right track. Finish simulating the process and figuring out what the elves need to do. How many rounds... Figure out where the elves need to go. What is the number of the first round where no elves move? Oh, that's easy. That's easy. Okay. Get rid of this. Oh, no, sorry. Leave that in here. Get rid of the print or the this. So the first round where elves don't move. Actually, what we're gonna do here is if I equals 9, do a quick lap. This is for step 10. This is part 1. And then we need the first one where they don't move, which means We just need a Boolean. That's easy. Because all we gotta do is go through here and update each else position, because we never did. So we just need to do if we need a Boolean moved equals false. If elf e equals this. Sorry about the train that's going by. If e dot position equals p, not equals p, moved equals true. If not moved, part 2. Whoa, hold on. Just print I plus 1, right? Because it's the step. I don't know. Okay. 925. Hey, we got both parts. Okay, let me... That was pretty far off then. That took almost an hour. Go to the game. So yeah, part 2 wasn't much harder. It's just I took forever to get freaking part 1. Okay, let me fix this. So what you need to do is moved up here. False. True. Sorry. So moved is there. But we set move to false here. And then that works. So now this can just become a while moved. Or is it step? Is that what they called it? Round. Round is 10. Round. Number plus 1. And so now in theory, this should go and only give us one number. Hey! Beautiful. What's... Alright, get rid of the print. I don't need no more print here. Clean this up. Clean up the code before we go and explain. So, welcome to day 23. Not bad. Finally, we get one that wasn't too bad. It solves in about a minute, or not a minute, about a second. Cool. So, solve this. So today is actually just game of life. I mean, there's infinite variations of game of life. Today's problem is simply just solving game of life. If you don't know this, you can Google it, look it up. Basically, it's just predetermined movements, and you kind of find where they equalize out. But yeah, so for today, what we do is we just go through our inputs. We parse this into a big list of elves and their positions, and then we begin our process of moving them. To do that, we simply create a map here of the 2 move positions. We go through the elves. We go through each elf. For each elf, we get the position that they want to go to. This is just this logic. We first check to see if they want to move. If there is no elf around them, then they don't want to move, so we just skip over this. If they do want to move, we then check to the north, south, west, and east, given their instructions and how that works. Don't forget, though, to do this choices logic here where we remove, we take the first one, we put at the end, so it just kind of keeps rotating them through. The way I explained that was the confusing bit. The way I explained that was confusing to me. But we do that, we check, and then for the first direction that we find that it wants to go in, we return that direction, or return the position in that direction. And then once that is done, we then check to see if this location is a bad location. A bad location, we add a position to the bad locations list here if 2 elves try to go to it at the same time. So as we kind of build up this list of where elves want to go, if we ever get to a point here where an elf chooses to go to position, but we already have an elf going there, we say, okay, 2 elves can't go to the same position. So what we do is we remove the elf from the 2 moves, so you're not going there anymore. You're going back to where you originally were, which is the position held in the elf. We add the elf that also want to go there, say, okay, you can't move there either. You stay where you are. And then we add this location to the bad locations list, which then prevents any future elf from going there. Because if we didn't, well, we would still have an elf in a bad location in our 2 move that's going there. So that's why we have the separate list here. So then if it is not a bad location and there isn't elf already moving there, that means it's free to go. We go ahead and we move that elf. We propose that elf is going to move there. In the other case, though, if it is a bad location, we say you can't move there. 2 elves have already tried to move there. You can't move there either. So stay where you are. That then runs for all the elves. So then every elf gets added to this 2 move location with where they want to go. We then simply update elves to be that to move. And then we process if any elf has moved. Luckily, because we have a position on the elf, and that was actually a bug I found for myself the first time, but this proved to be a feature, I guess you could say. We already have where we are updating the elf's position based upon where they have moved, based upon the map key. And so while we're doing that, we can just go ahead and just check to see if an elf has moved. And if it has, we can update this little move thing. This will end the loop if no elf moves, which also coincidentally outputs our part 2 answer. But also if we get to round 10, we output our round 1 answer by doing get empty, which just does a simple min-max for the row and columns, and then iterates over them, increments a empty counter here, and then returns that. So not too difficult. I think the comprehension for me is just reading today. But at any rate, day 23 is complete. Yeah. Only got 2 more to go. So anyways, you guys watch it. See you guys all tomorrow for day 24 on Christmas Eve. Peace out.